Welcome to our demo of the SPK Trace Report Engine, a powerful enhancement to PTC Integrity. PTC Integrity Lifecycle Manager is an industry-leading requirements management tool, and it provides unparalleled support for traceability across all the artifacts of the product development lifecycle. However, the built-in reporting capabilities of PTC Integrity Lifecycle Manager are not as robust as the trace management capabilities of the product. Reporting is an essential aspect of compliance and traceability management. You need to show external stakeholders and auditors that processes were followed and regulations complied with. And in order to do that, you need to be able to generate the right reports from the data contained within PTC Integrity. SPK and Associates have stepped in to address this need by developing a reporting engine specifically targeting traceability and compliance reporting. Today I'm going to demonstrate the features of the SPK Trace Report Engine and contrast them against the out-of-the-box reporting available from PTC Integrity Lifecycle Manager. Here are some of the key features of the SPK Trace Reporting Engine. As we will demonstrate, the SPK Trace Reporting Engine handles complex document structures and sophisticated multi-document traceability scenarios. Report authors have control over what is displayed, in what order, right down to color, font, alignment, and column width of individual cells. The SPK Trace Report Engine allows for highly tailored report generation in a format that many organizations are used to working with, Microsoft Excel. This permits organizations to generate and disseminate reports that are similar to or completely compliant with existing manual reporting templates. Finally, the SPK Trace Report Engine is an established commercial product already in use at several medical device companies. For this demonstration, we are working with data from a fictional medical device company, which we will call MedDevco. A key set of reports for the medical device industry are the Design Input-Output Validation Report and the Design Input-Output Trace Verification Report, which collectively are referred to as the DIOVV, or Design Input-Output Verification and Validation Report. As this diagram shows, the data model behind that report encompasses 4 document domains: the input document domain, the design specification document domain, the verification and validation document domain, and the test protocol domain. Our first demonstration will focus on the Design Input-Output Validation Report, which, as the diagram indicates via the green outlines, is primarily focused on the input document domain. This schematic shows the artifacts within the documents that are meaningful from a traceability and compliance perspective. However, there could be other elements such as headings and comments within such documents, and often documents contain multiple levels of decomposition for a given type of artifact. The ability to handle this variability is the big difference between SPK's Trace Report Engine and PTC's built-in reporting. Let me show you what I mean. We start the demo inside the PTC Integrity client with an input document instance that conforms to the nominal structure shown in the previous diagram. It has a single layer of top-level headings, underneath that a single layer of user need artifacts, underneath those a single layer of design inputs, and finally a single layer of performance requirements. I've constructed a DIOV report using the PTC Integrity built-in reporting system based on an out-of-the-box report template that's intended for relationship following. As long as I've selected any content in the document, I can invoke the report, and it returns this HTML report, which cascades all the items in a vertical display and uses indenting to indicate the relationships between elements. Each row of the report corresponds to an item in the relationship map, with the columns displaying the contents of that item. The indenting can be very subtle and hard to follow on traceability reports with very deep relationship hierarchies. Your formatting options are pretty restricted with the out-of-the-box report recipe. The PTC Integrity report does provide a single-line summary about the document that the tracing started from, and as we can see, all the data from the input document is here, from user need number 1 all the way down to the performance requirement and design validation that trace from user need number 7. Now let me run the SPK Trace Report engine on the same document. Just like the built-in reporting of PTC Integrity, the SPK Trace Report engine provides the user with a menu that lets them select from the available list of report templates. So I will select the DIOV. The report templates of the SPK Trace Report engine are by default stored on the server, and this avoids the issue of distributing report templates to end users' desktops or laptops. Once the report has been generated, as shown here, the SPK Trace Report engine can open it directly within Microsoft Excel. As you can see, it generates a tabular trace matrix style report where the different artifacts occupy blocks of columns. So there's the user need, the design input, performance requirement, and validation means. And each row corresponds to a given trace path. So traceability is very explicit. All the cells in that given row are part of a distinct trace path. So row number 5 is user need number 1 going down to design input 1.1, going down to performance requirement for design input 1.1. And row number 8 would be from user need number 1 directly to validation item number 2. Now the graying out of cells is a very useful feature. It's just one of the many options within the SPK Trace Report engine. It can be very useful for quickly identifying missing artifacts along a particular trace path, or to focus the user's attention on the pertinent data of the report. While PTC Integrity built-in reporting can generate trace matrix style reports, it requires very complex custom report recipe authoring if you want a tabular report with any pertinent details. I'd just like to point out while we're here that we have control over a variety of formatting aspects. So up here in the header row, I've got a dark green background and I'm using a white font for the text. And down here in the footer row, I've got the same dark green background, but I'm using the default black text. For the priority field of the user need, I'm using color mapping to define the background color. So if the value is critical, it gets a color of red. If the value is high, it gets a color of yellow. If the value is medium, it gets turquoise. And then finally, if the value is low, it gets light blue. As I've mentioned repeatedly, we can't always count on the document structure remaining rigid and deterministic. So one common pattern that we see is where documents contain subheadings, and they could have a variable number of subheadings. So this is the case in this document that I've produced. It is an exact copy of the first document, except I've got 3 subheadings. User needs 1 and 2 are contained by the first subheading. User needs 3 and 4 are contained by the second subheading. User need 5 remains directly under the compulsory user needs top level heading, and 6 and 7 are underneath yet another subheading. So let's run the PTC DIOV report against this document. Notice that the report contains much less data. Basically, the PTC Integrity report template was not able to handle the additional level of subheadings. Only the results for user need number 5 were correctly shown. While this is not a usable report, at least it's obvious that the results are incorrect. The next example is not so obvious. The other pattern that we often see is decomposition. So in this document, again based off of document number 1, we have no subheadings this time, but we have decomposition of user needs. So the first user need has 1 level of decomposition with no fan out. The third user need has 2 levels of decomposition. At the first level, we have a fan out of 2 second level user needs. And for the second of those second level user needs, we have a further decomposition down to a third level of 2 user needs. And it is from that third level that we then trace to the design input. User need number 5 also has 1 level of decomposition, with the design inputs tracing from that lower level. So again, let's run the PTC Integrity report. This time we have more results in the report, but they are still not correct. While the trace data from user needs 2, 4, and 6 and 7 are properly rendered, we don't have the decomposition for user need number 1 or number 3 or number 5, which are the user needs that had decomposition applied to them. Again, the PTC Integrity Report was not able to handle the additional levels of decomposition. With PTC Integrity built-in reporting, you would need to construct a distinct report template for each possible variation in document structure, and the report presentation often doesn't make it obvious when the wrong report has been run. So let's try the same thing with the SPK trace report template that we used on the first document with these two documents. So going back to the second document with the subheadings, so when I run the report from the SPK trace report engine, it produces exactly the same results as for the first document. The additional subheadings were handled by the same report template thanks to the more robust definition of how to follow the relationships within PTC Integrity. The report template is only showing the top level headings of the starting document because that's how the report template is set up. However, by adjusting a single parameter in the report template, we could show all the subheadings as well. Here's a previously run version of the report that demonstrates that. So with this one where I've set the parameter to show all the subheadings, you can see I've got my top level heading, and then my first subheading, my second subheading, the next top level heading, and finally the last subheading. And now let's try the trace report engine again on the third document with the user needs decomposition. Again, all the traces were correctly followed. There is no missing data. The decomposed lower level user needs stack under their parent user needs within the report, which is as to be expected. Going back to the first document that we worked with, the document itself contains lots of interesting summary data. So let's look at the properties. And if I were to expand this out, we can see that in addition to its title, we have all sorts of annotation: intended use, intended indication, patient population, user profile. We've also got a change control and approvals tab. So I can see that there's a change control status table, and I can also see who the approval roles are. It would really be nice if we could demonstrate all of that data or illustrate all of that data in the report. And you can with the SPK trace report engine. So if I run the DIOV with overview report template, now I get a cover sheet which has been labeled intended use, and I get that in addition to my DIOV tab, which has the data we've seen before. So if we go back and we look at the intended use, I can see that I've got full control over the layout. The SPK trace report engine automatically sizes the heights of the fields so that data is displayed properly. And the SPK trace report engine is also able to handle embedded tables. So it has taken that change control status table and turned it into an embedded table within this overview worksheet. I also have support for labels. This demonstrates that we can take all of that additional annotation and descriptive information that's captured in the root document and put it into a cover sheet that is often necessary to complete the report. We also talked earlier about the fact that the design input-output verification and validation report is actually two reports. It's a DIOV and a DIOTV, which TV stands for trace verification. One other thing I would like to demonstrate is the ability to do the full DIOVV report in a single report template. So again, we have our intended use overview or cover sheet with all the necessary information. I have the DIOV tab that you have seen before in the previous demos, and I have the DIOTV tab. So I was able to produce two different reports from a single traversal of the data inside Integrity. As you can see on the DIOTV report, We also have color mapping fields. In this case, it's for the essential output column of the design output. And just to demonstrate again that the graying out of cells is intelligent, it actually can distinguish between an empty cell and a cell that has no value. I have this example with the design verification. So verification number 2 of design input 1-2 is empty, but it actually exists. And the SPK Trace Report Engine is able to make that distinction and display it as a blank cell, whereas the cells that don't exist are grayed out. This concludes our demonstration of the SPK Trace Report Engine. If you are interested and would care for more information, you can either check us out on our website at www.spkaa.com or phone us at 888-310-4540. Looking forward to hearing from you soon.